Hello everyone, this is Xia Chen from the GPS Science and Application Research Center. That is GPS ARC in the National Central University. Our team includes the National Central University, National Space Organization, and the Central Weather Bureau. I am very honored to be here to introduce our research technique. The topic is atmospheric monitoring and the application of FORMOSAT-7 radio occultation data. From the title, it is clear to see that our technique involves two parts. One is the atmospheric monitoring, and the other is the RO data application. The FORMOSAT-7 Cosmic 2 is a collaborative space program between Taiwan and the United States. It is a follow-on mission to the FORMOSAT-3 Cosmic. The FORMOSAT-7 satellite operates in the low Earth orbit and receives signals from the global navigation satellites. A signal passes through the atmosphere and has reflection, and then we can derive the atmospheric profile from the bending angle of the ray. The technique is called the radio occultation, that is RO. The Global Navigation Satellite System, GNSS RO data, are all weather obtained, which is minimally affected by aerosols, clouds, and precipitation. The data have high accuracy and high vertical resolution. The FORMOSAT-7 RO data have been used in the numerical weather prediction at global operational weather centers in Taiwan, United States, and Europe. This graph is provided by Taiwan Analysis Center for Cosmic, which is the TAC. It shows the daily FORMOSAT-7 RO data from the first profile till mid-September this year. After May 2021, the data amounts have increased to about 6,000 RO soundings per day. This slide shows the horizontal and vertical distribution of the FORMOSAT-7 RO data. The GNSS RO data are global coverage. Figure on the left-hand side shows more than 5,000 RO soundings can be obtained during a 12-hour period, and more than 52% of the data are contributed from FORMOSAT-7, as indicated in green dots. The figure on the right-hand side shows the penetration depth of the FORMOSAT-7 RO soundings. More than 80% of the data penetrate below 1 kilometer, which would be useful for atmosphere detection over the lower troposphere. For the GNSS RO data processing, there are 3 processing centers. Those are CDEC in the United States, TAC in Taiwan, and the RONSAP in UMassat. The processing algorithms in CDEC and TAC are the same. For technological independence, our team developed a RO retrieval system, which is the Taiwan Radio Occultation Processing System, aka TROPS. The atmosphere retrieval algorithm in TROPS is developed by NSPO for the reflectivity and by NCU GPS ARC for the atmospheric temperature and the moisture profile. The red box shows the full chart of the TROPS system, and the TROPS 1DVAR system has been operationally performed in CW TAC. TROPS system is self-developed by the Taiwan team, and it has been operated in near real time. It is also free to be downloaded from the TAC website. TAC is an operational center for the FORMOSAT-3 and the FORMOSAT-7 RO data, and it controls the TROPS system to process automatically. It is also maintaining and monitoring the system programs to ensure everything goes through successfully. Then the RO products are provided to numerical weather predictions, government agencies, and public users. For the atmosphere monitoring, TRAPS retrieved the high-resolution FORMOSAT-7 RO profile that can construct a 3D meteorological field. The near real-time environmental monitoring, especially over the northwestern Pacific Ocean, it is displayed on the GPS website. Figure on the right-hand side shows an example of the retrieved pressure from the FORMOSAT-7 RO data. Let's point out the location of Typhoon Surigate in 2021. The pattern in pressure is also comparable with the NCEP global analysis. Another example shows the recent typhoon events. Those are Typhoon Changchu and the Typhoon Kangsen. The FORMOSAT-7 RO data can successfully detect the locations of both the typhoons, as indicated in the red and blue circles. It also shows higher relative humidity over this region. For the applications of RO data, we conduct data assimilation with FORMOSAT-7 RO soundings on severe weather predictions. Figure on the right-hand side shows that RO data assimilation has the best performance on the prediction of typhoon tracks and the frontal rainfall. It is diverse for the applications of GNSS RO data. The inference could relate to disaster prevention, life safety, economy, agriculture, research, etc. On the other way, early awareness of tropical cyclone genesis would be helpful for disaster prevention. Based on our previous study in Channel 2020, we further applied the non-local reflectivity operator with FORMOSAT-7 RO data in the advanced hybrid data assimilation system to detect tropical cyclone genesis. The processing system and the detection platform have been implemented at the NCU GPSR. This animation shows the result with and without our data assimilation to predict the genesis of Typhoon Huckabee in 2020. The model forecast with FORMOSAT-7 RO data shows the genesis time the same as the observed. That is a good simulation. Without the RO data assimilation, it shows no cyclone genesis. The simulation of cyclone genesis by RO data assimilation can be an additional reference for weather forecasting and air and sea transportations. It is a new aspect of the industrial application of the RO data. Thank you for your attention. Please feel free to contact me if you have any questions.